That's this one. Well, what is here? Here. It fits down into it, so it relates to another Platonic form, and the triangles that make up the icosahedron are the same triangles that make up the top, makes up the, well, I don't have that drawing here, but there's the triangle right here, that's at the top of the icosahedron, and the top of this chestahedron are exactly the same. Okay, so let me go back to this. Yeah, see, I'm going back to this again. That red pink line is root 3. And root 3 is the distance between, okay, corners, diagonal corners. That's amazing. That happens to be 36 degrees. All right. I found that the form fits in a cube. I could get a 7-sided form to fit into this cube. Can you believe it? This has 6 faces. That has 7. How can I get that into here? I found out that I could if I put it at root 3. So here I did. I put it at root 3, and this is what it looks like. I need to find out where this form is coming from. If I could find out where it's coming from in this process, then maybe I'll find it in the world. Okay, so let's see if I can find that little guy. And there he is. Here's the 7-sided form in the cube. Now, it had a relationship to the cube that I was interested in, so I divided this into 16 squares, and I found out that the corners hit at the corner of the first square. It just so happens to be, you know, right where I could measure it easily. Huh? I could get this baby right on. And that's so amazing that it does that all over. And the point comes right to the end, and that's why the 7 will fit. This is called root 3. See how it fits in at root 3, okay? So this part right here is called the apex, and this is called the base. All right. So I knew that if I had this blocked off into squares like this, if I followed this in either direction, I could find out where it came from. So that's what I did. I took the next one, which was here, and then I'll see if I can line these up. Give me a little time. I have to get the root 3 just right. Not always easy. I think that's right. I followed it from the corner of the cube to the middle, right there. Right there is the middle. The form is right between the two. The 7-sided form is right between the corner and the middle of the face. And here it is. This shows the progress spinning of a form inside a cube. So here's the 7-sided form, the first square. And if I keep turning this 7-sided form, it grows and turns into a tetrahedron. This thing is a tetrahedron. That's where this thing is coming from, is this form. Now, if I continue it down, so I went from the corner tetrahedron to the middle of the first square, to the edge of the first square. Okay, here it is at the middle of the second square, and now it's at the very middle of the cube. And it turns into an octahedron with one stellated corner. It turns into an octahedron, so it's going from fire to air. This form is between fire and air. This is a transitional form between these. Now let me show you what a transitional form is. This is what I'm interested in, is transitions. This is a Platonic form, okay? It's solid, it's here, it's even. If I take this form, which is green, okay, and I throw it over this hand, okay, it'll turn into an orange. Now, I'm interested in this part. I'm not interested in this part. This is established, it's even. I'm interested in this odd one, which is called an interval. Okay, so I know you want to see that again. There it is. Nope. There it is. Okay, so let me see if I can show you this. I want to show you the rotation in the cube. So here's how it works. This is how it moves in the cube. Right in the middle, it goes all the way over, becomes a tetrahedron again. It's going across, hits the middle, it's an octahedron, goes all the way across, expands, tetrahedron. So it's between this one and this one. All right, but the tetrahedron has to fit into a cube, because that's where it takes place in the cube. So if I put this in here, it's too big. Don't get discouraged, it fits in perfect. All right, so let me show you the significance of this form, because this is going to be on this campus. Okay, so if I start out here, I make a chart real quick, and I make this a hexahedron, which is the cube, and I make this an octahedron. So that's this one and this one. And what's really great about this, the octahedron is a reversal of this. So watch this. This will go into here, and when I turn it just right, it will be in the middle of all the faces of a cube. That is amazing. All right, so let's take the characteristics of a cube. Let's see here. These are getting dry, but maybe this other one will work. Oh, is that going to work okay? Huh?
Yeah.
Yeah, well, I think, let me try this one. This blue one might be okay. Yeah, this blue is good. Okay, we'll start with a hex. The cube. Okay, so how many faces? We'll see how many faces, because that's what I was really interested in. So does anybody know how many faces the cube has? 6, right? Easy, 6 faces. Okay, and let's put another in here. Okay, how many corners? 8. There are 8 corners. So this would be corners. They call these vertices, but they're corners. Okay, there are 8. Let's see what else. How many, let's see. What is the shape of the side? Well, in other words, what are the shapes of the faces? They're all squares, aren't they? Yeah. Okay. And how many edges? There are 12. Somebody knows this. Yeah. Yeah. Okay, these are edges. There's 12. Okay, that's simple. Let's take the octahedron here. How many faces? There's 1, 2, 3, 4, 8. Okay, and then how many corners? 6. And what is the shape of the sides? They're triangles, aren't they? Okay. And how many edges?
12 again.
There are 12. Isn't that interesting? All right, let's take the 7. Okay. How many faces? 7. I should get it. Let's see if I don't. I have one here. Okay. How many corners? How many points? 7. How many edges? 12. And the shape is between these two. It has 3 quadrilaterals and 4 triangles. So you can see here is we got the 7 between here and the 7 between here. Look at that. That's fantastic that this is happening. So this form is a perfect form, but is it a platonic form?
It isn't, or it is?
What's that?
Did you say
Is it? Is it?
Is it a platonic form?
It's a Chester form.
Well, you know, I named it that because it's in the chest, yeah? This form is in the chest. But it's not a platonic form. It's a transitional form. Okay. So, let me show you what I did. I wanted to find out where this form was coming from. So, here this is the interesting part. If I can get these lined up. Okay, cube goes over here. Icosahedron goes here, octahedron here, and, oh, thank you very much. Wow, I can really draw now. Okay, so this is what's different. Okay, so all the studies that I've been doing is making it different. This is edges only. No faces, they're gone. So I studied everything was different. Then I put it into points only. This is what it looks like in points only. Same form, points only. Okay, so I did a whole bunch of stuff, 100 things that I'm not going to show you, but just basically tell you, I'm trying to find out what's different. And what's different is, well, the things I showed you. See how it's different than the other platonic form? That's what's different. Earth is all about what's different, okay? It's the only one that's square. It has the 4 directions. This is what's changing. What I had to do is try to change this form. So the only thing I could do, it's very strong, I couldn't twist it, I couldn't push it. The only thing I could do to change this was to spin it. And there's where your bell came from. This is the geometry of a bell. I don't know if you can see those black lines. Maybe if I, let's see if I can reverse this and maybe I can get something lighter on the screen. And you see these black lines? Okay, they're lawful. This isn't fantasy at all. This isn't subjective. This is objective. I studied every one of those, and of course I drew them up. And I also studied this one too, and the other ones that I did. And look at these lines. These lines are altogether different. And when you twist it, look at the lines. It's gorgeous. And what you have to do is you have to draw these up. Okay, yeah, I can see them, but I have to draw them accurate. So this is what's changing. The form changes. Okay. This is what's reversing. So I had to turn this inside out. And this was really a problem because there's a barrier between water and air. And that barrier is even found on the ocean. That's why you have all the bubbles that land up on the sand, is because there's a barrier that's caught the air. And to show you this is that when people are in storms, and they get in a lifeboat, and there's waves all the way around. They have this pyramid-shaped thing they keep olive oil in. And there's a little valve at the bottom, and they let this go into the water and turn that valve on so it drips out, and the olive oil spreads out, and there's no waves. There's waves all the way around this boat, but where they are is perfectly smooth. That's because they've broken up minimum surfaces. They've broken up this barrier. So this was a barrier for me to try to find how to turn this thing inside out. And this is what it looks like turned inside out. And I finally found it out. It took a long time to figure it out. But that's what this form, another new form, turned inside out. You're going to say, well, what do you mean inside out? Well, you have to check yourself to make sure that everything is lawful. So there should be 2/7. This is lawful. Okay, I turned it inside out. Now the next one is fire, and fire is what's transformations. And I found that the fire is what we call an inversion. An inversion was studied, okay, by a mathematician in Switzerland that was directed by Rudolf Steiner to turn a cube into an inversion. And he did. And here it is. See, I first started to figure out that this, you know, how 6 would be on the Saturn. Anyway, inside here I have what he did. What he did was he took a cube and he took one corner out.